Good afternoon, student of the course 2009. Here we are taking a look at some of the goodies that we have in the Arduino package, and today we're going to study a few here. And I'm right now in my shack. There's a little bit of noise, but don't worry about it. Sounds like I have a dinosaur somewhere here, but it's not. Anyway, let's see what we have in this package. This is from the Crystal Electronic kit, Arduino kit, and I'm opening this one. As you can see, there's a few chips here. I'm gonna take those out. We're not gonna mess with those, not now. But there's some very interesting and cool ones. Are these ones that have these tiny bits at the front. We're gonna take a look to those in a second. And let's see what else I got here. All right, there's some. These are called piezoelectric. These are kind of tiny speakers, can be used for some project to make some noise. They're kind of cool. And these are photoresistor. Actually, let's take a deep look to these. Let's see if I can focus better the camera. Let me hold it. Anyway, it looks like that's the best I can do. Alright, this is a photoresistor. It's sort of like a solar, well, it's a mini solar cell basically, a tiny, and but it changes its resistance value when there's light, and when it's dark. If I put my finger in top of it, you will see the resistance changing the value. It's kind of cool. You can do many experiments with this. Pretty much this is the stuff that is used in camera, just to know when to turn on the flash or not, you know, automatically, or to do adjustment to your screen when you are in a very sunny day, and so forth. And so how it works, very simple. Let's pick one of those like this. Let's pull this to the side, and let's use a meter, and let's measure the resistance value. I'm gonna put this. I'm gonna use the select button, sorry, and let's put this to measure. There we go. Now, if I put one of the leg here and the other, and I use this one here, so you will see. Let's see if I can get this a lot better. There we go. You can see a value there, about 2 kOhms. I'm in my shack right now. It's a little bit kind of sunny day, so if I put my finger in top of it while doing this measurement, I would love to have some alligator clips, but I don't have it right now here where I'm located. So anyway, put my finger in top of it, and you can see that it went right to kind of over, but now it's having some reading. So a dark reading would be about 14 kOhms. When there's enough light where I'm located, it's about 2. If I move this to a more light area or lighter area, let's see if I can do that. That value might drop a little bit more. So, but I will have to get this out of the camera. I don't want to do that. But anyway, give you a good idea that this photoresistor change resistance as is illuminated. If I put my finger back again, you can see that the value jumped to about 15 kOhms. So you can use these as a sensor for your Arduino, to let the Arduino or your software know where it's lighting, you know, where there's enough light in that particular room to do some stuff on based on the reading that you're having from your photoresistor. Well, that's basically it with the photoresistor. Now there's one tiny element, which is kind of cool. Well, it's hard to pretty much to see it. Let's see if I can get a background here, a white background, so you can see what I'm talking about. Let's see if I can. All right, there we go. That very tiny element, it is a thermistor. So it will change, again, its resistance value will change according to temperature. Let's take a look at it before. So in other words, let's see if I can do this. Again, put your one of the leg to one of your meter and the other leg here. If I can get this right where I want to see everything. And you get a value of about, let's put this right, get my hands out of the way, about 7.7, somewhere 7.6, and that value is at room temperature. Right now it's about, I would say, 85 down here where I'm located. If I put this in hot water or warm water, let's see that I think that this water is still warm. No, it's already, I have some water here, but since it took me for a while to get this to this point, it's not that hot at all. In fact, I don't think it will change anything if I put this here and submerge the tip of the unit, so that, let's see if I can take a look to this. If I right now I'm putting the other leg of the meter right there. So if I submerge this into that water, well, it kind of dropped a little bit. It's not a big deal, but it's telling you that yes, take it out of that warm water, it's coming up again, about 8 or so. There's a little bit of a breeze that is kind of cooling, since the sensor is kind of wet, so it's evaporating the water and it's kind of cooling it down. If I put it back in the warm water, let's put it back in, see how the resistance value drop again. So this is what we're gonna do. We're gonna use this guy to make a thermometer. That's what we're gonna do. It's a very simple thermometer. I mean, we don't expect much of it, but it will tell you somehow the temperature if you calibrate. If you calibrate this unit, it will give you a good, I would say, a plus minus 2 degrees, which obviously is not that great, but give you a good idea of what to do in case you want to take a decision based on temperature, whether you want to turn on a fan or whether you want to turn on a cooling pump, you know, flow or something. This thermistor will do the trick. This costs about 10 cents. It's included in the kit, and it's kind of nice. You can buy this separately, and you can buy a lot better than this one. But this is what we have in our Arduino kit, and that's what we're going to be using. We're going to prepare this and see how can we do that. First thing that we need to do is try to avoid that these two contacts get together. We can do that with I will use a piece of straw. You can use a piece of straw, or you can use some I would say, let's see, what can I use? A cable cover, that will do as well. A tiny cable cover, one in this side and one on this side, and then put a little bit of hot glue right here at the, not covering the tip, but you know, let's see if I can focus that better, right here with the cable cover, and that will do. So the next part will be to solder some long cables, about 3 feet long, and we will have our thermometer, basically based on a thermistor. Let me set that out for you. All right, so hold for 1 second here. let's see. This is a piece of wire, you know. You can see that the wire is inside. I just need a cover, so just a little bit of it, perhaps just to make this part here, you know, put a little bit right here, and to separate them, and then, you know, leave enough of this tip to solder something, and do the same in this side, and then put a little bit, as I said, of hot glue right here, and that will do. So I'm gonna, now let me get this cover out of the wire. You can do that with some electrical pliers here, and bite the little bit the cover and then pull until it get kind of loose enough. So there we go. So here is the cover, the wire cover, but ready to do something else. I'm gonna stick it right, let's see if I can. This is so tiny, you need nails to get this. So the idea is to put this inside here. See, there we go. And now I'm gonna do the same with the other one, so that in this part here, right here, I will try my best not to put too much hot glue, you know, above. So the idea is that only the tip get without the glue or the hot glue, and everything else I put, you know, a decent amount of glue, so just to ensure that there is not a short circuit at the sensor. Alright, so let me use the other piece that I need to do that job here. The other piece might come right through this other piece, that little cover. Let's see, let me clean them up a little bit so it's easy to pull. And now let's see how easy I'm pulling. You know, I can use another plier and that will do the job easier. Hold it for a second here. Let me look for another plier. Alright, I found another plier here. Again, sorry for the noise. I think that I have sounds like I have a dinosaur somewhere here. Whoops. Okay, almost. Let's see if I can grab it right through the star so I can pull. There we go, that's the job easier. Now it's easy to pull. There we go. So I have it right here. This is the part that I was interested. You can do this easier if you have a very tiny straw. I mean, these are very tiny thermistor. Well, let's see, put in my finger, you can see how small it is. So I'm putting this right here. And there we go. So now that's it. What I need to do is put a little bit of hot glue at the tip, try not to you know, kind of put too much glue that it kind of cover the tip. I don't want that, because if you cover the tip, then it's gonna be, you have a very slow response, and you don't want that. Sometimes some thermistors have a well, you know, that this go inside another stuff for protection, and but then that kind of delay the temperature reading, because the content of the well need to pass that temperature to the thermistor itself, so that take a while. I think we are pretty much done with this. Again, if you happen to have let's say a straw, a tiny straw, the one that you use for coffee, let's see. Like this one, it's a very tiny. You can certainly use this and will make perhaps your thermistor wire cover easy. You see how easy it goes through, and this is a very tiny one. But I want to try with this. With you see, this is what I want to avoid. This has to stay all the time covering the cable, so that has to be right there. I'm thinking maybe what I should do is put it like this and put the hot glue right there. So I think that would be better. So something like this. This will go this way, and that will go that way. And the other thing that you could use is one of those shrink plastic for when you do when you connect cables. That would be like easier and probably waterproof, because you definitely want this to be waterproof. All right, so I guess that now I only have to put some glue at the tip, and I pretty much have a nice thermistor that I can use for reading some, at least plus minus 2 degree temperatures. We'll see how well this goes. All right, I'm back now. Listen, this is what I did. I put the covers right at the tip of the sensor, but I also put some cable gauge number 22, because this will go, the other tips of this cable will go right to the breadboard. So 22 gauge is nice, and it's also nice because basically this thermistor is also gauge 22. So I can solder them, but you happen not to have the soldering equipment, but you can wrap it up a little bit. What I will do now is put some of the glue, because it's hot already and I'm wasting time, so I need to put some glue. I can certainly put glue right here, just to start to cover this a little bit, just to make water. And so this one, you can put tape, you can wrap it with tape. I'm putting kind of a decent amount of glue. Let's see if I can later on stick this out from the table, my working table here. Let's see, the idea is to have some of them covered with that, and that will do. It look messy. Maybe I should put and let's see if I can put a drop right at the tip. This will be hard. I'm doing it. That will do by that side. The idea is that those guys never touch each other, and there is also watertight. They should be watertight. Let's see. Need to put a little bit of glue. Let's see. I'm not sure whether all this is showing. Right there is the thermistor, the tip. So this part, I'm adding a drop just to ensure that it's sealed as best I can seal it. Yeah. The idea is to be as watertight as possible, except that I leave the tip. I'm not sure whether you are watching all this. Let's see. Okay, still wet, but it's getting the job done. Oof, that's kind of hot, still hot. So let's get my fingers out of the way. And it definitely looks, to me, it looks very tight already. Well sealed. I will put a little bit of masking tape, perhaps, or duct, no duct tape, I mean electrical tape, right through here, just in case there's a wire that might get into contact somewhere here in the middle, just to ensure this is the way it should be. But wow, put this back here. Sorry for that. It's just, I'm not sure why the camera refused to too much stuff. Perhaps it's not doing. There we go. You can see the tip right there. Trying to. Everything else has a lot of hot glue, but the tip doesn't, which is good. Let's see. Yeah, it's clean. And everything else is a mess with the hot glue, which is not a big deal. But here you have a fancy thermistor, because that's what the kit had. The kit had this thermistor, and you have to put the legs to it, and it's about, the length of the leg here is about 3 feet. That's what I cut this cable. Right here, 3 feet, because again, you are messing, probably you want to measure the temperature of water or doing something with the water, so you want your Arduino as far as possible from where you will be messing with water. So, but this will do. Now let me finish this by putting some gonna be putting some electrical tape to this part here, and again putting a decent amount of glue because the machine is still going on. Let me do that right now. Alright, so yes, you know, kind of a decent amount, just for water protection. And now I can definitely put a little bit more of the hot glue in, you know, kind of decent amount. So put a little bit, yeah, of course, just to be sure that this is kind of sealed, no water. And I think out of hot glue. Yeah, it's kind of, yeah, that's basically it. We let these two cool, and we now have a very, very fancy thermistor that we're gonna be testing. Just to ensure, I'm putting a little bit more on the right at where I might get water by capillary action. I don't want that water to go through. I want this, in fact, I might want to add a little bit more right at the tip there, and then use a knife to cut any excess in top of the tip. But I just wanted to be sure that it's well covered. No water can get into. How about that? Weird, but it works. It will work. We'll test it. Let's leave this to cool a little bit. Probably, see, if I put a lot of hot glue here, it might be, when I check those.
Too much glue, the resistance value will be kind of slow in the response.
That will do. We can put it in kind of a water with ice, so that gives you a reading about 0 degrees centigrade, and boiling water. So you got between 0 and 100. So you can do a kind of a rough, I would say rough calibration curve. Very rough, but it will get the job done with 2 points. You can get another one, but for another one you might need like a true temperature sensor, and then use for comparison so that you can build a nice calibration curve with many points, 10, 20 points, so you have the whole a good range of testing your sensor. But if you don't have a thermometer, then what we will do is just as I said, two good well-known temperatures, which is water freezing point at 0 degrees. Put water with ice, little, leave it a little while, a few minutes. All right, the camera kind of battery run out, so anyway, give me an opportunity to prepare this setup. Hot water on this side. You can see here, hot water. Found some alligator creep hanging around, so great. And in the other side I have water with ice, and that will do. Remember that the calibration shall be done with the length of cable that you plan to use. Might add a little bit, might change a little bit your calibration, so better be sure that you are ready to use the cable, the length that you're planning to use. Right now, let's see. This is room temperature, whatever it is, which I don't know. Might be about 85 degrees C right now. I mean, Fahrenheit. 85 degrees Fahrenheit. So it might be about close to, I don't know, 27, 28 degrees centigrade. And here is our sensor. All right, look good. Put a lot of glue on it. In fact, I put a little bit right at the top as well. So it doesn't matter, actually. It's well protected now, but it will take a few more seconds to calibrate with the water that you're trying to measure the temperature. So let's see, when I stick this, our rudimentary thermistor design into hot water, and let's see what happens. Actually, let's take a look to the resistance value, and while I dip this in hot water. See, it's taking a little bit longer than a few more seconds. It's coming down because it has the protection. Maybe I should get that out for a better reading, for a faster reading. But eventually we'll equilibrate. Might take about a few seconds to equilibrate. It's not boiling water, by the way. I'm just stick this cup of water in the microwave for a few seconds and took it out, and that's it. So I'm not doing calibration. Actually, let's see how hot it is. It's not that hot. You'll see I can put my finger in. It's about, if I have a good finger calibration temperature, stick it in. Wow, it's about 80. I mean, you don't want to leave your finger there for hanging too long because it's hot. But it's not boiling. 337, it seemed like a calibrate. Took about 10 seconds to calibrate. So it might be that I have too much. Let's see if I can. You can put this guy in front so you can take a look at it. See, I put a little bit of glue at the top of it. So that glue tends to interfere a little bit how fast the thermistor equilibrate with the temperature of the solution you're trying to measure. But anyway, so let's get to the cold side. Let's see what happened. So I'm kind of getting a good reading of the temperature outside any of the cups. So let's put that in the cold water. So let me move this to here so you can still see what I'm doing. I'm gonna put that right here on this one. Let me pull from a little bit so you take a look. Submerge it in cold water. Now it's going to the other side. See how fast? Actually, leave it there because the idea is this. Now let me pull a pencil here. I would say that's decent 0 degree water. So whatever is the reading, I'm gonna put some numbers here, like for example, let's do a calibration. So I'm doing the temperature that I think that I have here. Obviously I don't have a thermometer on the cold side. I would say 0 degrees C. Okay, so and the reading that I'm getting is about, let's see if this is stabilized, but it looks like 24 something. Let's see. So it's about 24 point. This is the temperature in degrees C, and this is the resistance value in ohms or kilo ohms. Actually, kilo ohms. That's what I'm reading. Kilo ohms. So it's about 24.77. Kind of a clip right there. I don't know. You know, you can pull a lot of value when you have all this set up in the Arduino. You can do a fancy calibration, but that will do. So you are about 24.72 kilo ohms. Now let's go in back to the hot water side. On the hot water, stick it there. On the hot. And the hot, I said, let's see. I'm putting my finger back again because my cold off a little bit. Well, it's kind of hot. It's still hot. Actually, let me look for a thermometer. I think that I have one somewhere here. Hold it for 1 second. All right, I found this in my toolbox. Kind of cool. It's a weird, huge temperature sensor. It's an industrial sensor. Let's see, the blue. I can read the temperature of the room right now, which is about 29 degrees C. Kind of hot here. It's a very sunny day, very low wind, so it's kind of hot, 29. Now, let's stick it in the hot water and see what's the temperature of the hot water. Let's see how well my finger is calibrated. Shouldn't be 40, it should be more hot than that. Where is it? Felt more like 60. It's going up, but very slowly. Well, my finger is way off. I mean, it feels a lot more hot than what I'm getting here on this sensor right now. The reading is about 40 something, 42. No, actually 41 degrees C. Well, why it feels so hot for my finger? Let's see what's going on. Well, it is hot for my finger. Well, I don't know. Maybe this is not that great. I have to check this guy. Well, but that's the reason. That's what I got. It says 40. If I check this the best I can, 41. Actually, it's about 46. It's going up a little bit. 46. I said it feels like 60 degrees. It feels very hot. Going up a little bit. Leave it there. Oops, the sensor kind of that's always bad. Oops. That's why you don't want to have too many things close nearby, because always there's an accident. This is very heavy stuff. This is very heavy. Nothing. I mean, my Arduino was far away, so no, don't worry about it. Let's see. Going back here. The last reading was about 4 something. see if I can. There we go. It says, well, my last reading was about 46, I will say. So I have 46, let's see. Yep, 46 degrees C and about 4.42 kOhms. Let me see if I can get another temperature hotter than that. So I got 3 points. But at least with these 2 points, there's a big difference in the resistance value. So I definitely can have a very nice calibration curve with those 2 values. At least within this range of temperature. Maybe I want to take a look at what happens when I get this very hot, this water very hot. Hold it for 1 second here. Alright, I'm back again. I kind of heat them up, the hot water, and let's see, I'm having a reading close to 85. Now it's hot. No, I don't want to even stick my finger there. Let's see, actually not 85, sorry for that. It's some 60 something. The something is about it's about 70 now, and the reading of the thermistor is about 2 kOhms. So I would say about 69. Well, actually, let's see. Well, to me, it's almost a baby step. Let's see if I can focus better this. It's about 70, but it's not there yet. So, what is the temperature? Harder to read with this sensor, but anyway, it's about 60, 68, definitely. That's what it is, 68. Yep, 68. Let me get this sucker out because this is very heavy and you don't want water running again, making a mess here. So it's about 68. So again, be extremely careful when you handle cold water, hot water, because it definitely can cause trouble. So right now the reading is about 1.93. So let's use that. 68 degrees, and I have a reading of 1. It's going up because it's getting cold. So let's say 1.93 at that time. That's it. KOhms as well. So anyway, this is what I have. 3 points. That's good enough. Basically, I can't really get to hot water, very hot water, but I have to go to the kitchen. I have the microwave back there, and then run down here. It doesn't, it's not worth the effort. 3 points good enough. So I'm really, I'm confident that any reading between here, between 0 degree and 68, will be reflected right within this value. So let me take my thermistor, my kind of nice thermistor, and again I can leave it right now at room temperature, like let it cool a little bit because it's kind of hot, and that reading will be the reading on my shack right here, which is kind of hot. I measured with my sensor before with this guy, and let's see if I can put this 20. It's kind of wet. Let me dry it. Let me see back again. Still showing a kind of a very hot temperature, which is not, but it's going down. It's going down slowly, but it's going down. Take a little while for all. I mean, this is a thermal well, so all these tip gotta get within certain temperature, and it take a while to cool down, and eventually reflect that right here. As you can see, it's coming down. Right now it's about 34, coming down a little bit higher than 34. Let's get my pencil here. This big line will be 30, 32, 34. It's coming down, and that will be kind of room temperature. Let's check the resistance value. Is holding a lot faster than this guy. Again, just because of this is massive, right? So, and this has to be, this would be in a vessel that the temperature will not be like spinning. I mean, the temperature would be moving and so slow that this guy, I mean, the sensor will calibrate with the water or the solution at within the vessel. So not that what I'm doing now, that I move it around. I'm moving this around, and that take time for this big unit to calibrate. Well, it's getting there now. It's about 32. Yeah. So I'll leave it there for a while, and take a look here, see what this guy is doing. Kind of see what's them reading. Sure that the tip is dry. Let's see. Yeah, everything looks good. Cannot touch it because my hand is warm, and it will drop quickly. So I'll leave it there for a little while, and that will be another extra point on my. Let's see. Let's make this. So you take a deep look at what I'm doing on my calibration curve. So that point will then be somewhere obviously between 0 and 46. That point will be somewhere here, because I'm reading a resistance value of 8.33. So then the temperature will be between these two, which roughly, let's see what I got here on my sensor. See if you can read it right here with me. It's about 32. I'm dropping. It's gonna get about 30 somehow. Let's leave it to cool. And let me stop here for a second until this cool off, so I got that extra point. Alright, I'm back. I leave it to cool for a few minutes, and I'm back, and let's take a look here. So I'm reading 29. Took a while to get to that 29, but that's what it is. That's where we started as well, and 29 degrees C. There, 22, 24, 26, 28, almost half there. It's kind of hard, but that's it. Let's settle that to 29 degrees C. And what is the reading? 895. So, meaning that here, that point goes right here. That's 29. And here, this extra point here is 8.98. That will do. That's it. Now we have 4 points, good for my calibration. And let's take a look, see what happened. Let's go to Excel, do the calibration. Eventually, this will be used for a sensor, a temperature sensor for my Arduino to do some fancy stuff. And again, with a very, I will say this is like kind of weird thermistor build up. you know, look kind of ugly, but it get the job done. And for me, it's as pretty as it can get. It doesn't matter whether it's damn ugly, that only his mom will like it, but so far so good. Here you have it. There's two of these suckers within the electronic kit that you got. So if you damage one of them, wow, to damage one of these kit, really, I mean one of these sensors, you really have to do something really bad to it. I mean, I pull it, put some hot stuff on it, and it's still working, unless you hit it with a hammer. I don't think nothing will happen to it. I mean, obviously you guys are not kids, so definitely you will treat it, you know, with some respect, and definitely you will always have some consideration and proper kind of safety precaution when you are dealing with this guy. Hot water, it's still hot, believe me, it is hot, and I spilled some of it, and the only electronic equipment that I have hanging around was my 20-year-old meter. It would be bad if this guy kind of got damaged with water. But again, you know, I quickly did what I have to do, kind of pull, you know, move the things around and save what can be saved without hurting myself, right? Because I don't want that to happen. So, and I don't want that to happen to you either. So be extremely careful with hot water. That's when I never got this water to boiling point when I'm doing this kind of test, because that's kind of, you know, dangerous. Well, the camera got kind of weird when I put the hot water too close to it, but now it's going back. Anyway, that's the story. I hope that you learned something with it. Let me now go to my Excel and do some calibration and see how straight line the curve looks like, which I don't think so, but we'll see. See you in a second. Well, actually 2 seconds.
All right, here we are in Excel. Let's see whether we can get those 4 points and take a look to our calibration curve. I mean, to do a calibration with 2 points would be more than enough, but we're gonna check everything. Let's see if it's true what I'm saying. Like for example, the way that I put this together was, let's start here. So I said that would be the temperature, and that temperature, I got that temperature reading with my kind of weird industrial thermometer that almost caused an accident. Well, actually, it kind of a tip over my cup of water, but again, I was able to recover from there. That did not cause any permanent situation. Now, the other part is what the sensor is reading. Here is the thermistor. Now, the thermistor is reading kOhms. So we put the unit there so we know what we are doing, and the temperature actually here, let's say that is degree C. That's what we are reading. Whoops, that was ugly. Temperature, anyway, let's see if I get, oops. There we go, that's better. Now, the reading more or less that I did was 0 degrees. Actually, this was not read with the with the industrial thermometer, but I know it should be close to 0. I mean, those are part of the probably an error that I might have here, but that reading was about 24.77 kOhms. Then I read the 29, no problem there, and that was about 8.98 kOhms. And then I read the 46, which with my finger I thought it was hotter than that, 4.42, meaning that my finger is not well calibrated. I need to check that as well. How about the 68 was as hot as I got the water. We don't want to mess with hot water, you know. traveling with hot water from the kitchen to my shack. Not good. It's not worth it. So that was 1.93. Oops, 1.93. So I have the points. Now the question always come: what will be the x value, and what will be the y value for my graph? Remember, this value here will be read by the sensor. So we want to convert this value to this value. So to engineering unit, we want to convert this kilo ohm resistor value to temperature. Meaning that although I put this like this, like looks like this will be my x and this will be my y in my graph, actually it's the other way around. So think about it. What the Arduino will be doing, you actually, and in fact, I just have to say this clearly, the Arduino will not be reading this resistance value. It will be reading an equivalent voltage value, because we're going to be using an analog signal from the Arduino to read this value. I mean, hold your horses there. We don't want to go that way yet, but we will. At this point, we only want to do kind of a quick calibration to see how good is our sensor and how linear it is, at least to have an idea. So again, this will be my x and this will be my y. So as I always said, when you want to insert a graph, don't let Excel do it for you. You do what you want to do. For example, this is going to be points. Definitely, it's going to be points. And let's take a look at that. So we do select data, and then we add. And what will be the x? The x is going to be this value here. Whoops, too much. This one up to here. And what would be my y value? That would be the temperature from here to here. And let's call this calibration. Just okay. Calibration. That will do. And let's hit the OK. And let's hit the OK. Wow, not linear at all. As you can see, this 3 point might be, but then coming down here is not going linear at all. It's doing this curve here. This is very important, because in order to get the proper temperature down here, then we have to have in this, for example, if we are in this zone area here, you might use a linear curve, but from here to here there's something else happening. You can develop a whole curve that will do all the points, or will try to do all the points, and you can certainly do that, and but might not be that good after all. And sometimes what I end up doing is doing linear interpolation. For example, if I get a resistance value between 0 and 5, for example here, I will check some value, like for example, if I get a value of 2.5 in the kilo ohm zone. Actually, let's add a couple things here just so this looks better. How about I would say axis title, and so you know what I'm doing. So this is the resistance value, the sensor. These are the kilo ohms, and this is the temperature in degrees C. Temperature degrees C. And oops, that's ugly. I don't know why I hit that ugly. There we go. So again, what I was saying, if you happen to have a value somewhere here in this zone here, let's add more point here. Let's add this a little bit better. Let's see if I can get that. Yep. Measure, how about measure B? One might be 2.5 maybe. There we go. So you happen to have a value somewhere here. You see that 2.5 is very close. If I do a straight line here, so that value will be about 60 something degrees. See, and you can certainly use that for doing interpolation. And so with these two, and so with this one. So you are better off doing interpolation than trying to get a curve that do all of them. But I mean, certainly that's two ways you can do it. I try always, pretty much always do interpolation. I put all this point within the Arduino, and then the Arduino do sort of like equivalent reading here. Instead of reading ohms, I try to read voltage. And maybe it's kind of interesting. Maybe voltage is a little bit more linear than reading ohms right now. Reading ohms generate this kind of curve. Let's see, at 25 degrees, the reading will be somewhere here. I don't know. You see, between this point and this point, you will end up being somewhere here, a little bit higher than perhaps 12.5. It doesn't matter. I mean, what I'm saying is, the next time we'll talk about calibration, it's not gonna be directly kilo ohms. Will be voltage. I'm only checking how good is my sensor, how well it works. And at this point, I would say, although I might say how not to put together a thermistor, but it works. I mean, as I said, you have to hit it with a hammer really to damage it, but it's doing great. I It's a lot better than my finger. By the way, I mean my finger was off by 20 degrees, and I think this sensor well put in within Arduino might be with plus minus maybe even to 1 degree. It depends again with what we're using to read in the actual temperature. I use an industrial heavy thermometer to do this kind of rough calibration, and that might be part of some of the problem that I'm facing right now here, but we'll see. Again, we will do this kind of calibration again, but the axis here will not be kilo ohms, will be voltage, because we're going to be using one of the Arduino analog signal to read that sensor, the sensor that we kind of put together. I will say that's more than enough. As I always said, be very careful. COVID-19 is still out there. I mean, it's waiting for you to fall into the trap, and it will get you. So don't fall into the trap. Use your mask, protect yourself, protect your family, and be safe, whatever be your final destination. Have a great weekend. Bye.